Woohoo, we're live. Hi. This is Math 60 4.2 Solving Compound Inequalities, page 1. I know, this is very exciting. So what we're going to start off with is a couple of definitions of an intersection, which is written by this symbol, and then we write it over here next to the intersection. It looks kind of like a stylized N or a bridge, and union, which looks like a stylized U or an upside down bridge, or a smiley face and a sad face. And so we're going to look at the two concepts in math. An intersection is just what it sounds like an intersection between two roads. It is the overlap of two sets. So for example, when I look at these two sets right here, I see I have a 1 here and a 1 there. Since 1 is in both of them, it lies in the intersection. I look and I see I have a 2 here, but there's no 2 over here, so that is not in the intersection. 3, yes, it's in both of them, so 3 is in this set. And 5 is only in one of them, so it is not in the intersection. So the whole intersection, I know I give myself a ton of space, is just the set 1, 3. On the other hand, the union of two sets is just like a union is in English. It's bring everybody together. Everybody gets to come. So that means that we include all the elements from the first set, 1, 2, 3, plus any extra elements from the second set. So I've already got a 1 and a 3, but I need an additional 5. So you bring together all the elements in each of the sets together. And notice that even though 1 appears twice, I only write it once. So you include all of the elements just written once. So intersection is just the overlap. Union is everybody. So what does the Venn diagram look like? Well, if I have a couple of sets like this, then I could, let's see, I could go ahead and color in. This coloring is the best part. If I call this set A and this set B, then this is the union of A and B, is the blue. If, on the other hand, I call this set A and this set B, then in yellow, I look at that overlap between them. That is going to be the intersection of A and B right there. So that's the distinction between the two. So if we say intersection, there's that little bridge. It's a stylized N. That's written as and in math. This means you have to be members of both sets. The U stands for union, which we say as or, and that's a member of either set or possibly both. So here's how we're going to use this. Let me get this straight. There we go. So solve and graph. So I've actually got two different inequalities. I want -2 to be less than x, but I also want and x to be less than 1. So the way I'm going to approach this is I'm going to go ahead and graph each of those two inequalities. So I've got the first inequality right here, the -2 is less than x. I'll graph that first. And then x is less than 1. I'll graph that second. And then I'm going to use these two graphs to come up with the intersection. Remember, and is the intersection between. So -2 is less than x is a little weird to see. I'm going to rewrite it as x is greater than -2. That is kind of helpful because I'm going to put -2 here, and then I know x has to be greater than -2. So I'm going to graph it right there. And if you hear that, that's my cat scratching the wall. That means that math is very exciting. He scratches the walls anytime the math gets really exciting. Now this one, x is less than 1. I'm going to put 1 here. And the way I'm going to do this is I'm going to let it all overlap. So 1 will be there. and 1 will also be here. In the same way, this will be -2, and this will be -2. So I have, and they're a little slanted, but more or less straight. I've got the same scale on all the graphs, so they will line up. X is less than 1. I'm going to start at 1 and go to the left because that's a less than. And then I'm going to think, what points lie on both the first graph and the second graph? And hopefully this part kind of makes sense, that if you look here, these points that are right in the middle between -2 and 1 are the points that are overlapping. So over here, the first graph has all these points, but they aren't an overlap, so I'm not going to include them. This guy has all these points, but again, the first one doesn't have those, so I'm not going to include them. Just the points that exist in both graphs. I'm going to go to 2. Now, 2 exists in this graph. This is definitely a point, but this one does not. So I have to have an open, that parenthesis there. And over here on this edge point, end point, the 1 is definitely a point on this graph, but it's not here. It's just that open parenthesis. So I'm going to include that. So my answer is going to be all the points that are greater than -2, but less than 1, which kind of makes sense. I want -2 to be smaller than x. So x is bigger than -2 and smaller than 1. Which I can then write as an inequality or as an interval. Woohoo! Page 1 is done. Only 2,500 more pages to go.
Sorry, I think